Hello everyone, this is Chandrasekhar Chandamala. Welcome to the video solution of Cambridge IGCSE Physics Paper 6 Alternative to Practical October-November 2022. First question. A student investigates temperature changes when mixing hot and cold water. Figure 1.1 shows the setup. Observe the figure clearly whether all the apparatus are given or if any is missing. Question A. The thermometer in figure 1.2 shows room temperature theta r at the beginning of the experiment. Record theta r. So clearly in figure 1.2 thermometer is given and the level of the mercury is clearly given with a dark color. So we need to clearly, without any mistakes, we have to read the scale and write the answer. So clearly it is 23. Unit is already given in the question itself. So 23 degrees Celsius. Next, in B, there are some temperatures that are already printed on the question paper. Let us see what are those temperatures. The student records the temperature theta C of supply of cold water. So theta C is temperature of cold water, that is 19 degrees Celsius. She records the temperature of theta H of supply of hot water. So hot water temperature is 88 degrees Celsius. She immediately pours 100 centimeter cube of hot water into a beaker containing 100 centimeter cube of cold water. So in this sentence, dear students, we have to understand equal volumes. 100 centimeter cube is the unit of volume. So equal quantities of hot water is mixed with cold water. 100 centimeter cube hot water is mixed with 100 centimeter cube of cold water. She records the highest temperature theta m of the mixture. So m stands for mixture. Okay, the after mixing, the temperature of mixture is 46 degrees Celsius. Remember, this is recorded by the student who is performing this experiment. Suggest two precautions while you would take to obtain an accurate value for the highest temperature theta m of the mixture. So in order to make the thermometer reading more accurate, when two different temperatures of water is mixed, we need to wait for some time until the mixture gets a uniform temperature. So first point, it is for 2 marks, you can write any 2 points. So here I have given 4. Wait until whole water is uniformly mixed with hot and cold water and then take the temperature reading. Stir the water mixture before taking the temperature. So if we stir without wastage of time, then immediately we can get uniform temperature and that can be recorded by using thermometer. And when the temperature is recorded in thermometer, dear students, it is having a scale arrangement, so we have to avoid parallax error. So view the thermometer reading straight to the scale. Then last, whenever we are trying to arrange thermometer into the chemicals or liquids or any substances, we should ensure that the bulb of the thermometer is properly placed in the substance. It is not touching to the bottom or else touching to the walls of the beaker. See that the bulb of thermometer is not touching either walls or bottom of the beaker. So if you are taking these precautions, any 2 precautions if you write, it's enough to take the accurate temperature of the mixture. Then B2, calculate the decrease in temperature delta theta 1 of hot water using the equation delta theta 1 is equal to theta h minus theta m, include the unit. So when hot water is mixed with cold water, hot water is having high energy and when it is mixed with cold water it is having low energy, so energy will be decreased. So we need to calculate the amount of decrease in temperature. Formula is already given, just substitute the values. It is 42 degrees Celsius. Then another one, calculate the increase in temperature delta theta 2 of cold water. So cold water, it will gain the heat from cold hot water. So how much increase temperature is increased, we need to calculate. Again, formula is given. Just substitute what is mixture temperature theta m and cold water temperature, you will get it is 27 degrees Celsius. Clearly, your unit is not given, so we need to write the answer with unit clearly. Then question C, calculate the average theta A of the temperature theta H and theta C, hot water and cold water. Average we have to calculate here. Show your working, include the unit. So when two different temperatures are there, it is hot water and cold water. To take average, just add those two temperatures and divided by the number of temperatures. So it is 88 plus 19 divided by 2. We are showing the working here, and average temperature is 53.5 degrees Celsius. Here, dear students, you have to remember, this is theoretically calculated new temperature of the mixture. Before, already student recorded in the laboratory while performing the experiment, that is 46 degrees Celsius. So question D, state whether theta A, that is average temperature, and theta M, that is mixture temperature recorded by the student, can be considered to be equal within the limits of experimental accuracy. Justify your answer by reference to the results. So in order to check whether these two answers are same or identical, we need to find out the uncertainty by using this formula. Difference in the two temperatures divided by measured temperature into 100, and we got 17%. Actually, you are not needed to do this calculation part, but in order to find and give some justification, you need this. So when the percentage difference you are getting more than 10%, then the two values are not within the limits of accuracy. So clearly it is 17%. So the statement is the two values are not within the limits of experimental accuracy. So you can write no, and justification you can write the result is beyond the limit of accuracy. Then question D finished. Then last question is E. State two requirements when reading the volume of water in a measuring cylinder to obtain an accurate result. So here, while we are measuring volume of water using measuring cylinder, once again we need to remember here it is having a scale arrangement. So while we are reading the scale, we have to keep our eye straight to the scale, that is to avoid parallax error. And one more important thing, this is for 2 marks. So one more point is, when water is filled in a measuring cylinder, it will form a meniscus. So always we need to take the reading from bottom of the meniscus. Take the reading from bottom of the meniscus. So with this, we have completed first question. I hope you understood all the parts clearly. If you have any doubts, you can just comment it. Question number 2. A student investigates the position of the image in a plane mirror. Figure 2.1 shows the ray trace sheet. So on the question paper, actually only line MR is printed and two pins P3 and P4 are given. The rest of these lines and labeling, this number 7 centimeter, all are drawn by me for the coming questions. Okay, let us see what are those questions. Question A. Line MR shows the position of the plane mirror. Draw a normal to this line that passes through its center. Label the normal NL. Label the point at which NL crosses MR with the letter B. In this question, we have 4 works. First, we need to identify the midpoint of line MR. From the midpoint, using protractor, we need to draw a normal at an angle of 90 degrees. So perpendicularly we need to draw a normal, that too dotted line we have to draw, and we need to label it as one end should be labeled as N, the other end should be labeled as L. And where it is crossing line MR, that intersecting point should be labeled as B. So for all these four works, you will get 1 mark. So be careful. Question B, draw a line 7 centimeter long from B at an angle of incidence alpha is equal to 30 degrees to the normal below MR and to the left of the normal. Label the end of this line A. So just follow the instructions using your ruler. From point B you have to draw 7 centimeter. Using protractor you need to measure angle 30 degrees from the normal below MR and left side. So with these instructions you have to draw a line and the end of the line should be labeled B. So in this question we have three works. With roller we need to measure 7 centimeter. From the normal left side we need to measure angle 30 degrees and end of the line should be labeled as A. For all the three works we will get 1 mark. Question C. The student places the reflecting face of the mirror vertically on the line MR. He places two pins P1 and P2 on line AB at a suitable distance apart for this type of ray trace experiment. Suggest a suitable distance apart for pins P1 and P2 for this type of ray trace experiment. So usually in all the light experiments, when we are using pins, the minimum distance between two pins should be 5 centimeter and maximum 15 centimeters. So you can write that with unit, that is for 1 mark. State the reason for your suggested distance. So the reason for this distance is to get a ray trace more accurately. If the distance between two pins is very close, when we are drawing the line joining P1 and P2, we may get wrong angle of incidence. So that is the reason. To get a more accurate ray trace with the pins is the answer. Question D. The student views the images of pins P1 and P2 from the direction indicated by the eye in figure 2.1. So in the figure 2.1, at the bottom right side, eye is printed. There is eye diagram. So that means an observer is observing from down. He places two pins P3 and P4. So that pins P3 and P4 and the images of P2 and P1 all appear exactly one behind the other. The positions of P3 and P4 are marked on figure 2.1. Draw a line through the positions of P3 and P4. Continue the line until it meets MR. So just we have to join P3 and P4 until it meets the line MR where the mirror is placed. And D1, measure and record in table 2.1 the acute angle beta between the line through the positions of P3 and P4 and the line MR. So now we have to measure what is the angle beta through the positions of P3. Okay, we have already drawn a line which is passing through P3 and P4. So this line is making angle with the mirror, not to the normal. Okay, clearly angle is beta angle is to the line MR, not to the normal. So be careful while you are identifying what is this angle beta. Add units to the column headings in table 2.1. So already we know what are the characteristics of images formed by reflection or images formed in a plane mirror, and what are the laws of reflection. So if angle of incidence is 30 degrees, then angle of reflection, the line which is passing through P3 and P4 also will be 30 degrees. But beta is the angle between reflected ray and a line MR. So if the angle of reflection is 30 degrees, then the rest of the angle will be in a right angle. The rest of the angle will be 60 degrees. So beta is 60 degrees. Okay, it is in the second column. Beta is 60 degrees. So D question 2, add units to the column headings in table 2.1. So columns are given. This is alpha. And this is beta, alpha plus beta. So clearly this alpha beta are angle of incidence and angle of a line P3 and P4 and mirror. So this is also angle, so all are having degrees. The units are degrees. So first one beta is 60 degrees, and alpha plus beta, when we add these two values, we have to add these two columns and write in the third column, that is 30 plus 60 is 90 and 45 plus 46 is 91 degrees. Okay, then let's move on to the next question. Question E. The student places the reflecting face of the mirror vertically on the line MR with the center of the mirror at D. He repeats the procedure using an angle of incidence alpha of 45 degrees. The values of alpha and beta are recorded in table 2.1. Calculate and record in table 2.1 the values of alpha plus beta. So already alpha plus beta values, as it is clearly mentioned in the table, already they are calculated. So that is for 1 mark. Just if you are adding alpha plus beta that is given in column 1 and column 2, you will get 1 mark. Question F. Suggest a relationship, if any, between the two values of alpha plus beta in table 2.1. So in the first row, when you are adding alpha plus beta, you got 90 degrees. In the second row, when you are adding alpha and beta, you got 91 degrees. So what is the relation between these two values? Means these two values are almost same. Okay, they are identical. Two values are identical. Then question G. In order to investigate further a possible relationship between values of alpha plus beta, more values are required. Okay, so only with two rows of alpha and beta we cannot conclude the relationship. So in order to add some more values, here they are asking, suggest values of the angle of incidence alpha that the student could use. So already student did this alpha with two values, 30 degrees and 45 degrees. Then 30 degrees and 45 degrees, what is the difference? 15. So if you add one more 15 to 45, it will be 60 degrees. So your next angle is 60 degrees. And if you add one more angle, it will be 75 degrees. So with an increase of 15 degrees, you can take two more values. Okay, it should be less than 90 degrees. Angles with an increase of 15 degrees from 45 up to less than 90 degrees. Okay. So what is the increase from 30 to 45 and 45 to next already you have mentioned, and it should be less than 90 degrees. So for these two details you will get 2 marks. Then question H. The student does this experiment with care. Suggest a practical reason why the results may not be exactly those that the theory of reflection predicts. So how carefully the experiment was done also, there is some errors. There are some errors. Suggest a practical reason why the results may not be exactly matching with the theory of reflection predicts. Okay, the results are not very accurate, it seems. So what may be the reason? Okay, we need to write what is the reason for inaccuracy. So in these light related questions. Reasons for inaccuracy is the pencil lines what we have drawn might be very thick lines. Okay, so the pencil line should be as thin as possible. And when we are keeping the pins should be placed vertically, and even pins also should be taken as thin as possible. We should not take thick pins. Okay, and here also we have protractor. There is a scale arrangement, and we need to measure angle of incidence and angle of reflection. So while we are making these angles measurement, uh, it should be taken without a parallax error. Okay, so if we avoid, okay, since it is for 1 mark, you can write any one reason for getting not exactly the results that are expected from the reflection. Okay, so with this we have completed second question. I hope you understood all the details. For the diagram, you can just go back and see that uh, diagram, all the angles and line AB with 7 centimeters, how it is drawn. Okay, you can just go back and see the diagram. Let's move on to the next question.